All right, so I'm Brian Cronin. I'm from Unknown Worlds Entertainment, small game developer in San Francisco, and I'm the lead programmer. This is a small team, huge game, and Lua. So this is about our game Natural Selection 2. So I'll do a kind of quick overview of what that is. So first of all, the Unknown Worlds was formed in 2006 in San Francisco, and Natural Selection 2 development really kicked in sometime in 2007. I joined in 2010, and I'm the lead programmer there. I don't remember if I mentioned that. So we're a core team of about 9 people, but we work with a lot of other people all over the world. We have people who make levels in the UK, a programmer in Europe, sound guy in Australia, just all over the place. And it's a sequel to a modification of Half-Life. So the first game, Natural Selection 1, came out in 2002 and was successful, but not commercially. It was a free game for people that owned Half-Life. And so this new game is a commercial. It's on Steam, and it's a completely custom game engine. So we're not using Unreal or anything like that. So to give you a basic overview, it's Marines versus aliens, sci-fi. There's 2 very unique sides. So the Marines have technology, guns, jetpacks. They coordinate kind of top-down. And the aliens are like animals. They crawl on walls and fly around, and they're more bottom-up. So you could kind of see the infestation in the background there, and the Marines are fighting that back. It's completely online multiplayer. There's no single player. It's a client-server architecture. And it's also a strategy game. So there's a commander on each team, and they command the game from a top-down perspective and research and give orders and everything you'd expect from a real-time strategy game. So it's a first-person shooter and a real-time strategy game. We have a lot of dynamic features. So in the foreground there, you see the dynamic infestation, is what we call it. There's kind of an orange cyst on the ground up there that grows that infestation over time. And that's what the aliens use to push their way through the world and take over the map. And in the background there, you could kind of see the red lighting. There's also a power grid in the world that the Marines need to support to keep their structures powered, and the room is not powered up there, which is why it's red. So all the lighting is dynamic, very dynamic game, and it was just released. So we just got it out on Steam, and it's doing really well. So we're really happy with the success. So the engine is completely written in C++, DirectX, a physics library, not much else in terms of middleware. Sound library, but it's mainly just code that we wrote. And what I'm here to talk about is Lua. So the gameplay is entirely written in Lua. So this is Decoda. I was going to talk about this more in this presentation, but I didn't have time for that. I was curious though, does anybody here use Decoda? Okay, cool, a couple people. So yeah, the gameplay is entirely written in Lua. We don't have any, in terms of like what a player is or a weapon. Those are completely in Lua. The game engine doesn't have any concepts of what a weapon is. And we also ship all the Lua source code with the game. So that's the game director right there. And all the Lua code that we use is in there, which is really important for modding, which I'll talk at the end. So the overview of this is I'm going to talk about the integration in the game engine with Lua. And then the bulk of this talk is really about something I'm really passionate about, which is object-oriented programming without the hierarchy. So talk about the techniques we use to avoid some of the complexity you get with a very dense hierarchy. Then I'll talk a little bit about script errors and open development, modding, and so forth. So first, talk a little bit how we hook into the engine. So there's basically global events, and then there's NAD events. So the global events are very simple. It's like when the engine is going to tell you that a client was disconnected. So it'll just call that callback function, and you can handle that however you want. And then there's also console messages. We have a console in the game that you could drop down, and you could hook in any arbitrary kind of console. That's really useful for debugging. So that's all really simple, and Lua closures and stuff like that makes it really handy. Then entity events, which is really the more interesting part. And first, I should describe what an entity is. So an entity is how we really build the game world. It's a persistent networked object, meaning it's created on the server, and then all clients that have that entity relevant to it, which that's based on a lot of complicated rules, but in general, that's if you're close to it. I think it's like 45 meters by default. But for the commander, it's more complicated. It's depending on if his units have line of sight and stuff like that. But it's a networked object. It has a lot of fields that you could define, and we just use Lua tables for that. So if something's alive, its health, and so forth. It handles some complicated networking concepts like prediction lag compensation. I'm not going to go into that here, but there's some sort of complicated networking techniques that are all sort of automatically handled through the entities, and that we, the Lua game code really drives the game. So that's also handled through Lua, prediction and lag compensation. And in general, an entity is just a container for logic, physics, graphics, audio, etc. And some examples there on the bottom. And then it's also queryable, so you could kind of query what is nearby, which I'll show later in the talk, but is useful for if a grenade explodes, for example, find the nearby things to damage. So these go from the engine to a specific entity. So an entity might be a player, for example. And they're automatically networked, essentially. So when a player's initialized, destroyed, on-process move is really important. That's when the game engine is going to provide the input, the keyboard, mouse, and you can handle that however you want. So these are the types of events, just kind of callbacks that the engine calls. I have these cool picture breaks in here because this is a game, so I figured show off some cool stuff. So that's the hive right there, and the Marines have to destroy all the hives to win the game. All right, so here's the cool stuff. So object-oriented programming, we all know what that is. And traditionally, it's organized within a hierarchy, which has a lot of benefits. And the problem I've noticed working on games is these tend to get a bit extreme. So this was kind of what our hierarchy, and don't worry about the details too much. I'm just showing you kind of the point I'm making here. This hierarchy was even more complex than this, but it all started with good intentions, and like we're gonna have this actor, and it's going to have like game-related stuff, and then there's the blended actor for animation. The script actor was put in there at one point when the engine transitioned over to Lua, because it wasn't Lua originally, and it just got more and more complicated. That live script actor is important. That's for tracking if you're alive. I'll talk about a little bit more. So there was things like structures, players, different types of players, and so forth. So I want to talk about the problems with this type of structure. Specifically in a game, but this does apply in general, I believe. So there's a new piece of functionality you want to add, and this is just the concept of being cloaked. The game needs to have cloaked aliens, for example. And so we're going to have this cloaked actor class that we need to insert somewhere in the hierarchy. And so you need to decide where you want to put this. And one place is maybe everything that's alive has the ability to be cloaked. It may or may not be cloaked depending on game conditions. And that seems, pretty good. But then you determine later that, the armory, this marine structure, should not be cloaked. So we're going to move it down and just make it so that structures are cloaked, and we could decide which structures are going to be cloaked by inheriting off of that. So that seems pretty good. And then, 2 months later, we find out that we want to make alien players cloaked now as well. So now we have this problem. And so you kind of end up with something like this. Or where are you going to put this? And this is one problem I've noticed with a hierarchical approach to object-oriented programming. So another problem is overrides often lead to bugs. So this is something pretty simple, and we kind of have a similar object-oriented system to what's called Lua bind. We used a Lua bind originally, and then we moved to a custom sort of just PHP script that generates the bindings. And so we still have that object system. But so here's a Marine, and he is a player. So when the Marine's killed, we're going to call the player killed function. And in this made-up example, I'm going to remove 10 points when the Marine dies. So that's pretty simple, no bugs there. Later on, we add this another made-up thing, a quick respawn system, whatever that means. I don't even know. So we're going to check if some condition is right to do a quick respawn. And if it is, he's just going to respawn quick, and he didn't technically die, whatever. He doesn't lose points. And this is all fine until, later on some functionality is added to the player on kill that needs to be called in this case, and then you have some weird bug that's going to take you a day to track down. So I'm going to focus on right now this live script actor. And I think live script actor for me is a sort of a metaphor for a lot of different classes I've dealt with. It's really the class where I have a piece of functionality like cloaking, and I don't really know where to put it. Live script actor is a decent place, so let's put it there. And so I call it the overly responsible live script actor. And so it's supposed to just keep track of if you're alive, your health and armor values, stuff like that, taking damage. That's what it was supposed to be used for, what it was made for. It eventually took on things like being on fire and being cloaked, because that's okay, we'll put it there. Scoring, team, energy, it just went on, and just it kind of even goes down off this page probably. And I spent about 2 months on the project, kind of very much as a side project within the project, just refactoring live script actor away. Another quick, cool picture break. That's a fade there in the foreground. He kind of teleports around, and that marine is definitely going to die. Okay. So my solution to this was to use mixins, which many of you familiar with mixins as a concept? Okay, a good amount. I learned about them through Ruby a little bit. I don't use a lot of Ruby, but they call them modules there. It's a similar concept. A lot of languages use mixins. I think I have I have a somewhat unique take on mixins. Doesn't use all the conventions, but so I'm going to talk about how this helped me solve these two kind of core problems. So first of all, a mixin is just a piece of functionality. So you could kind of view it as a class, but it doesn't exist within a hierarchy. It attaches itself to an object. And it very much like my implementation, it kind of just copies itself onto the object. So it's very simple. It has a lot of sort of functionality that you could add on top of it, optional functionality. But the base idea is pretty simple. And most importantly, it's not organized within a hierarchy. So I'll go to this example again of the live script actor turned into this live mixin. Tearing apart live script actor probably generated like 20 of these mixins. Just taking all that functionality and breaking it apart. So it's just a Lua table. At its core, it's just a table with a type, the type of mixin, which I use for querying and stuff like that. So it has that init mixin is just it'll automatically be called when you add it to the object, just initialize data, and then a couple functions there that you add on. So pretty simple. So this is just an example of how that works. So the server is creating a player. We're going to give it the ability to be alive, essentially, with a init mixin, and then it could take damage and heal. The player doesn't have those concepts by default of being alive, so that's the basic idea there. So behind the scenes, again, it's a little more complicated now. Like we've moved this functionality into C for optimizations reasons because these mixin functions were being called like thousands of times, every frame. So it got kind of crazy, but generally, this is the idea, just copying the functions into the entity. So pretty simple. Yeah?
In Ruby, like mixins are not supposed to have their own dedicated state.
Right.
Here, so
No, like I do have, that right there, live mixin at the top. It adds the health in, so the player wouldn't have that health. That's why I say I have kind of my own conventions here for mixins. So it's not exactly the Ruby model or any other model. So they do define state here, which could potentially lead to problems, but in practice, I've never seen it in our game. Yeah, so that's the basic idea. And it gets a little more complicated, but that is the basic. So now I want to add this cloaking into the game. And so there's the cloakable mixin. It's a type cloak. And one feature of cloaking in the game is that when you take damage, you are no longer cloaked. So that's a pretty handy way to do that. And the obvious problem is if you have the cloak mixin and the live mixin on an entity, what happens? How is that resolved? Because these are just copied in, so it by default it's going to just, depending on the order you add them, it's going to override one of them. So that's not what I wanted. So there's a few options. You can only call the first function that was attached, but then you would lose this type of functionality of cloaking or taking damage on cloaking you. You could require explicit calls like a live mixin dot. Take damage. It's not really elegant. Or you could call all the functions attached. And so that's the approach I took, is just to call all of them. And so behind the scenes, again, it's pretty simple. You've seen this type of thing before. All we're doing is iterating through the mixin, If the function does not exist, so if take damage doesn't exist on a player, we're just adding that function right in. Just assume there's not going to be another take damage function. As soon as we encounter another take damage function, it's going to just do some magic there to kind of create a meta function that is going to call a list of all the functions that you add. So again, it's relatively a simple concept with some really cool behaviors. So then you have this type of thing. The same example, we're adding live and cloakable to the player. And the player is going to cloak, going to take some damage, and then we're going to check that it did not, that it's not cloaked anymore. So that's the kind of behavior you get as a result. So essentially this kind of turns function calls into more of a message system or an event. You're telling the entity that it has taken damage and telling how much damage it's taken, and it could do anything it wants. You could have some sound effect that plays based off this in some other mixin. We do a lot of things based on taking damage and welding and all sorts of game events like that. Another quick cool picture break. That's a flamethrower. I don't know why I have a lot of pictures here of them destroying the hive. There's also the aliens also do damage to Marines. Maybe I just favor Marines for some reason. Some whips are in the front that'll whack that Marine if he gets close to him. So yeah, the last part of mixins here I want to talk about is another cool property for games specifically. But it's like if you have a bomb and it's exploding, you could get all the nearby entities within 10 meters. We already had that sort of functionality in the game. This is what the code used to look like too, before mixins even. And then you just iterate over those and make them all take some damage. And that works fine until you have something like, let's say, a door that isn't alive and it's nearby. It's going to take damage, but it might not have that take damage function, and you have a script error. And so a really nice solution to this was to just support mixins within this query system. So when the mixins are added to an entity, they kind of, the engine doesn't know about mixins, but they're tagged based on the mixin name. So all the entities can have multiple tags, alive, cloak, etc. And then that goes through the query system. So this avoids that problem entirely. We know that this list of nearby entities is going to include everything that's alive. So we currently, last time I checked, had 109 mixins in NS2, and they include all sorts of things. The whole power system is based off, we have a power source and a power consumer, so it's very simple. And displaying of models and the collision and the model mixin is the most complicated thing in the game because it deals with collision, visuals, animation, the network synchronization, but that's handled through a mixin. We have a couple different types of model mixin. Movement, having orders, getting points, etc. So I wanted to talk about script errors, and specifically one little thing we've done with script errors that makes it really useful. So there's the typical line number and call stack, but we also track some of the state when the error occurred, and this is what's really useful for debugging. I don't know how many of you do this, but if you don't, hopefully I'll show you how cool it is. And then automatic collection, which we don't do yet, but I have an example of someone who does, and it's something we're looking into. So here's your typical script error. I could discern based off this that something was welded and there was some problem where there was a string compared with a number and not much else. I could go to the line and probably figure it out, but in some cases I can't. So we have this tool, which is just it's a very simple, this tool is actually written in Lua using like a WX widgets Lua wrapper. Anyway, so we just feed this thing the log file, and it will find all the errors inside that log and give you the call stack. And then most importantly, on the bottom left, it'll give you the state, all the locals on the stack at the time. So at the bottom there, I've highlighted health equals 10. And I can see right here that 10 is a string. It's probably not right. So I go to the code, and sure enough, in this invented script error, I passed in 10 as a string. But 10 might just be it might be a variable, so you would see that variable is actually a string versus a number. So useful stuff. And then I don't know, there's this game called Gary's Mod, which uses Lua. It's a really cool game, kind of a sandbox game, and they have this automatic collection of script errors. And for a game that is heavily modded, Gary's Mod is entirely mods. There's not much of a game there otherwise, so he really needs this. And our game, we have a game there that is pretty stable. We do have some script errors, but Not too many, but we do have a lot of mods as well. These mods do whatever they want, so they do produce script errors. And so getting reports of these would be really useful, and this is what he does. So he just has a list of, I think based on frequency, of all the script errors, and you could go into detail, and it shows you exactly when they started, so you could see based off of some change you made when they start to get reported. 7,000 reports up there. He has a lot of people playing his game. So that's a really cool system. We're going to be making something like this very soon, but I just want to show it off because it's neat. And the last thing I was going to talk about here was our open development process, and this involves a lot of things. Lua really helps with this, but it goes beyond that, even with how we get a lot of our community that plays the game is very creative, and throughout development helped us a lot in producing the game, making levels and a lot of bug fixes, optimizations even in Lua, and a lot of gameplay features as well. So, like one example of a funny gameplay feature, I came into the office in the morning, and there's this whip in the game that's an alien structure that is a melee turret, kind of. It'll just whip you. And a guy in our community sent me a video that was the whip in front of him, and he shot a grenade, and the whip hit the grenade back at him. And that wasn't something we considered or programmed. He just did it because Lua, and he could. And we instantly put that in the game because it was wonderful. So we have a translation system, which also is, this is a web service, but the translation system in the game is just in Lua. There's C++ does deal with that a little bit, but generally it's in Lua. And then this is a mod that we didn't make at all. This is called NS2 Stats. And this is a server will run this mod and collect all sorts of statistics about individual games and players, how many kills you make over a period of time. And so this is, the game server collects the stats and sends it off to somebody's web server, because we provide that type of functionality in the game to make web connections. And our dedicated server has a web server in it in addition, so people use that as like an administration system, and that's all coded in Lua. So we have like a web server in the game based off Lua. Yes? I don't know. I haven't investigated this. This is something that we should look into probably. There might be some imbalance there. I've just played this over the last weekend. There's people making, this is a mod called Combat. So the game is very strategic and involves collecting resources. But they made a combat mod, which was in the first game, and this is just going around shooting stuff. So it simplifies the game a lot, and it's a different game mode. But they added a Stargate level to it, which was really cool. And then there's, of course, a lot of kind of texture and models. Don't use Lua as much, but what's really cool is we have some full-on game modes coming online soon. Like this is a guy, again, not in our company, just a guy that really likes the game, and he's making a Marine versus Marine mod. So he doesn't like aliens, apparently. A lot of really cool stuff like that coming up, and that's all just due to Lua. We haven't even really documented anything yet either. They just kind of do it because they want to. So that's the talk. Thank you. So are there any questions? You want to get the mic, or?
So when you call multiple functions in your mixin with the same name, do you call them in kind of arbitrary order, or there is a specific order?
It's a good question. So there is a specific order. I think it's just based on, what we sort of standardized is that if the entity defines a function like take damage, meaning not in a mix, then that will always be called first. And that is important to depend on in some cases. Other than that, we don't really standardize that there's any, because they act more like events or messages, we don't say that there's any order, but I think it is based on the order that they're added. But yeah, we don't really standardize any order. That's never really come up, other than that first case of sometimes you do want to call the entity function first.
I was really interested in how you're capturing state when you have a script exception. Can you talk a little bit more about how you're doing that? Because that would be something that would help me a lot.
I didn't actually implement that part of it. The technical director did. I spend most of my time in script in Lua, so I don't. While I do have a C++ background, I don't spend so much time in C++. So the exact way he's doing that, I don't think it's anything fancy. I think he's just kind of going through the stack when there's a script error and the data's still there, so he pulls it out. It's not perfect. There are cases where I've noticed some state that I think should be there isn't there, but we're still improving it, and generally it works really well. But yeah, the specific details, if you could email me, and I could probably send you some specific details about how that works.
You were talking about how there's global hook events for game state and there's entity events.
Yeah.
This being a multiplayer game, are there any events that only fire on specific systems like keyboards and such?
Well, yeah, there's the client and the server. So those are the really two sort of. There's other. Those are kind of, I don't know what we'd really call them, but there's also like prediction, which is conceptually different from the client and the server. It only happens on the client, but it happens in you don't want to do everything that you do in the client in prediction. That's mainly for your movement to predict you forward in time from. It's complicated, but so yeah. To answer your question, yes, there are certain events that only trigger in certain kind of worlds, I guess. Like this on client disconnected. I think this is only fired on the server, for example. And then the console messages, it just depends, where you define those. So this event.hook is how you connect up to the engine through a console message or a predefined message. So if you put this type of console hello world in a file that's only loaded on the server, that console command's only on the server, and we also have a shared file that's loaded on both. So it kind of depends how you set that up.
Like I was referring more to the whole synchronization thing. Like I assume stuff like health deduction happens on the server,
right?
So
okay,
otherwise...
yeah. So these entities are. The authority for them is on the server. So for something to lose health, the server has to verify that, essentially. We do predict some of that stuff on the client, like when a player shoots another player, we'll draw a little bit of blood for that immediate feedback. But for something like health, that is something that only the server will have authority to change, and that'll automatically be networked through these network fields that you define on a class. We still do have a class hierarchy, by the way. It's definitely cut down from this type of thing, but we still do have a class hierarchy, and there's uses for it. I'm not advocating getting rid of it entirely, but definitely limiting it. So yeah, these types of events are synchronized mostly from the server to the client.
A couple of things. First, congratulations on the release. I know
Thank
it's
you.
been forever, so thanks for getting it out. And I'm not sure whether I should thank you or Max for Decoda, but thank you for Decoda as well.
Yeah, Max.
And now to ask some unfair questions you may not be able to answer. So at one point, you guys were licensing Decoda, and I know that kind of took a back seat, in terms of the source licensing because the game was in development and so forth. Is that a thing that you guys are going to look at redoing, or?
Well, we still do license Decoda. It's not maintained too much anymore. I mean, we do have some internal features that we have to push out.
Yeah.
But it is something that we all use Decoda. I use Decoda every day as just my IDE and debugger. So it's something we use internally, and we are investigating possibly hiring someone full time to just work on Decoda. Mm-hmm. Because that is something that we think will just kind of support itself and also benefit us. So we definitely want to push Decoda more. We see a lot of potential for that. I forgot to mention a couple things, not entirely related to that. Where is that? So there's the Decoda URL there. And also there's Max, the technical director, has a Lua VM up on GitHub called Rocket. It's not entirely done yet. It doesn't support every Lua feature. It's something worth looking into if you're interested. It's kind of a Lua VM more targeted for games. It's kind of the idea. But that's just something else I wanted to kind of show off, I guess.
And then two other quick, I guess, pointer questions. One was I noticed that one other people at Unknown Worlds were working with Love2D to do some kind of experiments around game balancing, creating their own kind of basic games or clients to figure out how to balance the thing. And if you could talk about that at all, I'd be interested. And then the second thing is, why did you guys decide to do your own engine? I realize you got there in 2010, so the decision may have already been made. But I'm looking at using Ogre for a couple of just as a rendering frame. and a couple of other things. And I was just wondering, like, what the design decisions you guys went through to stick with your own engine and throw out whatever else you had.
Okay, well, yeah. What was your first question again? I forgot.
Just if you could talk at all about
Love.
about Love TV and what people are doing in it.
So there was a little bit of prototyping by our game director. He's also a programmer. Using Love as just a way to prototype very simple game systems, early versions of that Infestation. We don't do it a whole lot, but occasionally we do. I use Love 2D a lot just for my own side projects, like a little hockey game I'm working on, whatever. So yeah, I use it a lot. We don't use it so much in the game company. Our engine is mature enough at this point where we mostly prototype in the engine. And then in terms of the decision to make our own engine, yeah, it was a couple years before I got there. But there was a lot of factors. Largely, I think it's just that the technical director, Max, is really the type of guy who wants to... I think a theme in this Lua conference I've noticed is that Lua is for people who want to do it themselves, sort of, which maybe also limits its scope a little bit. But he's this type of guy as well. So making the engine, he felt he could do it faster. We were using the Source engine, the Half-Life 2 engine originally, and he just felt that progress could be made faster without using that. And, whether that's true in terms of the amount of time we spent on the project, I don't know. But we've certainly gained a lot by doing it that way, and I think overall we're much happier as developers. And just in terms of Ogre, I've used that as well on my previous project, and it's a great rendering engine. That's all I'll comment there. But okay. All right, thanks.